Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is my tech, Philip Wilson.
Hello, everyone.
So, today's episode is going to be called Time as a Variable. And what we're going to be focusing on in this episode is we're going to be showing how you can change the speed of time in a game. So you can do slow down effects, speed up effects, etc. I'm going to show you some of the caveats and tricks about actually changing the time. And if we do more than one episode on this subject, I might even go into how to do reversing time. We're going to touch on it briefly in this episode, but it's not going to be useful in the way that you think it'll be useful yet. But we might touch on it. It's much more complex than just slowing down or speeding up time. So without much further ado, here is a project that I've started. This is one of the few episodes I've got a pre-project here. This is all stuff that you've done before. I mostly just wanted to have some stuff moving in the scene so that we didn't have to spend the time during the episode getting these things moving, so we can spend more time playing with time. So what I've got here is I've got a cube that's using an animation, just playing it left and right. This is a sphere that's moving in a circle. I'll probably make another object that does another script movement as well. And then this is just a particle effect that's playing.
Just a simple particle emitter.
Yeah, just a simple particle emitter. I didn't even change the default settings. I just basically threw one in here. So, so the reason I have this is just so that we can play around with time and see how things work. So let's start up a new script. We're going to create C# script, and we're going to call this time. What do we want to call this? We don't want to call it just time because that's the built-in library name.
The passage of time.
The passage of time. I'm going to go with time manager.
I think that's a good name. That's what I would name it.
All right. And time manager. Yeah, time manager will be good. So first, let's do a really basic setup here, so that we can see how you change the time rate on the game, and it's actually super easy. You're gonna love this. But as I said, the reason I'm doing the episode is because there's caveats and things that you're gonna want to do that are not as obvious. So we're just gonna do a void on GUI here, just for a quick and dirty graphical user interface, and we're just going to do a what are we gonna do? Just a slider. So GUI layout. Slider, go with horizontal slider, float value. So we're going to need public float time rate equals 1.0 f. So we're going to put in time rate here. Left value, let's make that 0.0 for right now. Right value, let's make that go up to
5.
Alright, 5 times.
Sure.
Make them, mark them as floats. And we don't need any other options, I don't think.
I think that's it.
Oh yeah, we have to do one more thing here. We need to actually do time rate equals. What this does is, if you're doing GUI layout, this horizontal slider returns a float based on what it's set to, and on GUI gets called basically when it gets redrawn or when it gets reset. So what this does is it means that it'll keep this variable whatever the slider is set to, and also what the variable here means that if the variable is changed elsewhere, it'll change the slider to match,
which is a good thing.
Yes. So
should give us a really nice display of what the time rate is at all the time, even if we slow it down with the script. Yeah.
So finally, we just need to actually plug this into the thing that actually cares about this. This is just a variable at this point. So time dot which one is it? I always forget this. It's time scale. So time dot time scale represents your current time scale. If you make this 0.5 is half. If you make it 2 is double. So we're just going to set time dot time scale equal to time rate in the update loop. I guess we could do that in the... I'm not going to do that in the GUI just in case there's weirdnesses. So if we hit play now, nothing changes because we didn't attach the script to anything. So
yeah.
We can attach this to the first person controller. Why not?
It doesn't really matter in this case, does it?
No, it doesn't. So, we see the slider there. Did I set my values wrong somehow?
I just don't. Maybe there's a slider. Go back and see what the last value was on the slider in the script. It might be a size.
Gui Layout should have handled that for me, shouldn't
so.
have?
I think so.
Right, left value, right value. Yeah, that should have.
You would think so. That's very
Alright, let's just do Gui Dot Horizontal Slider and see how that one works. Okay, so that one needs a rect position.
And it would be a 0 to 1.
U rect 0, comma 0, comma width, I don't know,
50.
100.
100 sounds good.
Height 10. Let's go with that. Let's see what that does. So is the rest of this right? Okay. Value, left value, right value. Okay. Cool. There we go. That's a little bit better.
That's kind of more what we were looking for.
Yes. So I'm going to go up here. Oh, I hate that I'm mouse moving right now. I'll switch to the scene view so that we can see how things are going. So, gonna need both of these. So now if we adjust the slider, you'll see that if we adjust it low, everything goes to a stop, and if we adjust it up, everything goes faster. So it already works. We already have a working case for time manipulation in the game. We've got it hooked up to a slider, which is not terribly useful in most games unless your game is a game about having a time slider.
Yeah.
Time slider. Great name for a game. Do it. Make it. So we now have time manipulation. All we did was change the time scale here. So I want to show you what's actually happening behind the scenes a little bit, so that you understand why this works and what's actually happening. So we've got these objects that are moving. One of them is a particle system. One of them has an animation. And those ones are internally handled by Unity, and obviously they respect the time scale. Mm-hmm. Now, this object here respects the time scale as well, but this is using my own little script here called circle move. And so the magic that actually makes this respect the time scale is time.delta times equals speed. This is the thing that makes it frame rate independent. It also is what makes this work, because if the time scale is set to 50%, time.delta time will return values that are half their normal size. And so what will happen is it'll be as if less time has elapsed, and so your objects will move less. So if you forget to do time.delta time, you'll notice that this won't actually work on your stuff. This is caveat number 1. If you don't set time.delta time, first of all,
look at it go.
Yeah, first of all, it goes 60 times faster because it's going faster. And second of all, nothing we do will change how fast it goes. Everything else stops and it just keeps going full speed.
Yeah. It's doing a linear calculation.
Yeah. It's doing a per frame movement as opposed to a per second movement, which is the other problem of not multiplying in time.delta time.
Yeah.
So that's basically how it works. So it's actually simple. It's not as complex as it seems. It doesn't seem very complex yet. But now the complexities for this come in manipulating time in such a way that's smooth. And what I mean by that is, say you want to slow down time to 50% for 3 seconds. You probably already know what the problem is by the way I just said that.
Yeah.
But if you slow the time to 50%, 3 seconds becomes 6 seconds. So if you have like a special effect where you want to slow down time until it stops, you've got to be able to keep track of time separate of that stopping thing. So we're going to set up our time manager to be really cool and really useful in a way that allows us to make these changes, and it keeps track of it for us. It keeps track of the proper amount of time changed, and it can smoothly transition between different time rates. So let's start on that now. So time manager. So the first thing we're going to do is let's change this thing into a singleton. So we've done singletons a couple times in the past. I have a file in here called singleton example that I'm going to be pulling from. This is probably a good thing to have in your project, even though it doesn't really do anything. And there's probably a way that you can set this up as a child-parent hierarchy, you may have a different singleton pattern that you want to use. If you know what a singleton pattern is, use whatever one you want. I'm just using this one because it's simple and we've gone over it before. So I'm just going to paste in our singleton stuff here. And I'm actually going to put this at the bottom so that it doesn't bother us. It doesn't really matter where things are in C#. But this way, at least, we're not thinking about it. And then the example here, we have to make sure that we change all of the cases where it says singleton examples to be time manager. So time manager, time manager. Actually, let's do refactor, rename.
Ooh, fun times.
Time manager. Okay, got most of them. Didn't get these two because they were in strings. Time. Whoops. Time manager. And time manager. This one just has a $sign because I like to sort things at the top, and that makes it so that it sorts at the top. And actually, I don't even need that line because it's doing it here. I wanted to explain one line here that I've not actually used on the show before. Actually, there's two things in this line that I haven't used on the show before. One, this question mark operator. I didn't even know this existed until like a minute ago. And so I haven't even actually tested it to see if it works. But theoretically, this will return instance if it exists and is not null. And if it is null, it will create a new game object called time manager. This is the other thing that I didn't know about. You can pass a name to the new operator for game object, and it will automatically name the object.
That's pretty cool.
Yeah. So all this does is, and this is a little bit more complex than our usual one. What this is a singleton. So it keeps track of its instance. It sets its instance when you call for it. Actually, that's new. And then if another instance already exists, it destroys the new one. So you can put this in all your levels, and you'll only have one of them, even though it says not to destroy unload. And you can also just put it in your first level. But the reason you use a singleton like this is so that you can put one in each level. Mm-hmm. You're not going to trounce yourself because it'll kill itself properly. And then this is a convenience thing. Before we just did return instance, this one actually creates the object for you. So if you call the instance, it creates itself if it needs to. And I'll show you why that's useful in a bit. It means that we don't even have to worry about actually putting it in the scene.
That's pretty
But we
awesome.
could if we needed to. So this doesn't need to be public. I'm going to put this at private. And actually, we're probably not even going to use that anymore anyway. But so this is now a singleton. Let's make sure that it at least works. Let's just do a test here. I'm going to...
It's still attached to the first-person controller.
I'm going to unattach it from there because it really shouldn't be on there, especially not as a singleton that wants to rename itself.
Yeah.
And we're going to just drag... Can I do this? I swear that worked once. When did that work?
I don't know.
I must have been just dreaming or something. I swear I dragged a script in and it was just like, oh, I'll create an empty game object and put a script on there. So
that would be awesome if it did.
It would. So I'm just going to put this here. We hit play and it still says game object. Maybe this doesn't work.
It would be unfortunate.
Let's just check it. Name. Can I just do that? Name equals time manager. Or do I have to specify game object? We'll find out in a second here. That fixed it. I don't even have to specify game object. That's cool.
Yeah, that's really neat.
All right, so, and then let's just do the double check. Let's create a duplicate of this game object, and then in theory, we should just see
one of them.
Perfect, it worked. So our singleton works. So singleton doesn't help us right now because all it does is this GUI thing. We don't care about this. I'm going to get rid of the GUI thing. We don't need it anymore.
Oh,
just going to get rid of it.
I already miss it.
Get rid of all of it.
I miss all of it.
All right, so I used awake in the singleton stuff. You might have cases where you need to put more code in here. Just remember it's down here. I used awake so that we can use start separately. Awake's probably more appropriate for singleton instancing anyway.
Yeah.
And so you probably won't even notice this is down here, in theory. But if you get a problem where it's like two awake functions exist, you'll get some... As a matter of fact, let's find out what it does. void awake. So if you decided to do an awake function of your own, you might get this error. Time manager awake already defined. So that's what it'll say if this is a problem. But don't do that.
Yeah.
All right, so we're going to create a couple of functions that will allow us to manipulate time. So let's make a function called void change
Change time.
Change time. What is it? Time scale. Change time scale, and we're gonna have it take a float new time scale, and then let's just start with that.
You can always add more later.
Yep, we can add more later. So change time scale, new time scale. We're just gonna do time scale equals new time scale. And so that's that. So let's get rid of our test objects here. So we're going to test to see if the automatic instantiation stuff will work. So theoretically, this should just be simple. We're going to create a new script. I'm going to say change time scale on trigger. So it'll look like that. Reload.
Ooh.
Oh, save. Oh, don't save. Close without saving. Wait, I want to save this one though. I'm just going to cancel.
Yeah, good call.
Already contains a definition for time manager. Oh. What is this file? Singleton example. Why did I change this? I shouldn't have. Okay. I'm just going to delete it. No, I want it there for people, so. I think when I did that fancy thing, it did everything.
Yeah, I'm pretty sure it did. That's what it looks like.
I wonder why that name thing didn't work. Oh well. So does that fix our problem? There it does. All right, so we're going to go back to change time scale and trigger. When I say go back, I mean we're going to open it for the first time. Why is it not opening? All right, die mono develop.
Do not
try it again.
Mono develop.
I'm going to quit mono develop, and I'm going to reopen it.
Not being helpful right now.
All right, there we go.
Okay,
finally,
good.
change time scale and trigger. So void on trigger enter. So instead of just setting the time scale here, which we could do, that's still valid, we're going to be using our system exclusively to change time scale, which will make it so that our system doesn't have to worry about keeping track of the state except for the state that it knows about. So just keep that in mind. We could have just done time.timescale in this case. It's going to be more complicated soon, so it won't work in the future. But let's actually see if it works with our new library. So we're going to do time manager.instance, which should get us our instance. And if it doesn't exist, create one for us. And then we're going to do dot. It's not in this list because we didn't make it public. Hello. All right, there we go. So I'm going to just go back into time manager and make sure that we set this as public. Void change timescale. So now we do time manager dot instance dot change timescale, and we're going to set the new timescale to 0.5 f.
So time will move at half as fast.
And actually, let's do public time scale, or public float new time scale. 0.5f. I'll just default it to something that's not full speed. New time scale. And then finally, void on trigger exit. We will set time back up to full. Time manager dot instance dot change time scale 1.0f. So let's go ahead and create a cube. I'm gonna make it bigger. We're gonna set it to a trigger. I'm gonna make it, where is it? I'm gonna create a semi-transparent texture for it real quick.
That's
so
probably a
material, transparent red. Let's set it to red, and we'll set it to transparent diffuse, and we'll click this because all that hid away. By the way, if this disappears for you, that's what happened. You clicked up here.
Yeah.
And then change the alpha down to something sensible. That's probably good enough. So we're going to give this to our new cube, and we're going to make our cube bigger. 3 by 3 by 3, why not? Let's do it that way. And so this one will slow down time to 50% by putting the change time scale on trigger on the cube. So if we hit play on this and go into our game, we should see that time slows down. There we go. It all slowed down.
Including your movement.
Including my movement.
But only when you're inside of it.
Yeah, but only when I'm inside of it. It goes back to normal time when we get out of it. So one of the things that you'll notice, or not, because neither of these are a proper example for it, is... Yeah, I don't have a good example for this. Actually, I do have an example. So the character's moving. So these things move smoothly, but the character's moving choppy. And part of the reason for that is the physics system. So like if we create a... what can we do that'll be physical? If we create a cube that... Okay, so... What did we do last time? We just did... oh yeah, I remember what we did. We're going to create... I'm just going to create a cylinder... I'm talking about last time, as if there was a last time. But if you guys don't know, last episode... We did this episode once, and my computer ate it. So,
yeah.
And hopefully it's not eating this one.
We're going to hope that that's not the case.
Yeah. So let's just have the cylinder here. I'm going to put a physics rigid body on it, because this is going to explain to us caveat number 2 here. So, yeah, that's fine. We're just going to make it so that it's frozen position. We're not going to freeze the rotation, and we're just going to add a... Let's see if I can just do a constant force or something.
Oh, yeah.
Is this what I did last time?
Yeah. Last time. There was no last time.
Alright, let's rotate it around.
It's along Y, maybe?
No, along Y would be bad. We want to be along either Z or X, I think.
Oh, yeah.
Just try 50 and see what it does.
Yeah. That works.
Alright, so we have this thing spinning here. Now, if I go into the field here, you'll see that it looks kind of choppy. And actually, if we make the field even worse than it currently is, let's change the variable here
like
to
0.1.
0.1? Right.
Yeah, we'll demonstrate it really well.
Yep.
0.1.
So
you have to make your character stop moving.
So my character has stopped moving. So you'll see that the sphere's moving pretty smoothly, the cube's moving pretty smoothly, and that tube is moving really choppy. Also, the player's still moving choppy. And it's kind of for similar reasons. The player's actually because of a different reason. It is similar though. So one of the ways you can fix this is there's a really super easy way of doing it, and that is you can just change the interpolation rules on here. So a lot of people don't seem to realize this. You can set an interpolation to interpolate or extrapolate, and what that means is if you set it to interpolate, they both basically do very similar things. But interpolate means that if it's between, like, if at a fixed time step it's in one position and at a fixed time step it's in another position, it will actually do a linear interpolation between those two values. The extrapolation is similar. It's predicting the next values. In practice, you're not going to see much of a difference. If we turn this on, you'll immediately see that it fixes our problem, so this thing now moves smoothly. It's not moving 100% accurately to what the physics is doing, but it moves smoothly. Now, that is one way to fix that, but I actually prefer another one. If we're going to be slowing down time, we should increase the rate at which we do the fixed time step. And what I mean by that is, so if time is slow, you can afford to have more fixed time steps. So if you're at 50% speed, you should have double the fixed time steps as you do at 100% speed. This gives you better physical accuracy for your simulation. It costs you nothing compared to normal time. And so I highly recommend it if you're doing slow motion stuff. So let's see how to do that. So I've turned this back to interpolate. So let's just make sure this is broken real quick. Yep. So what we're going to do is, in our time manager, we're going to actually make it more cool now. So instead of just setting the time scale to the new time scale, we're going to, in the start function, figure out the default physics time scale. So that's time dot fixed delta time. So time dot fixed delta time, we're going to store that. So public float, actually we're going to make private float fixed original fixed delta time. So on start, fixed delta original fixed delta time equals time dot fixed delta time. I would get it eventually. I knew it. All right. And so now we're going to set. So the reason I do this is you can set the fixed delta time in the editor. It's in edit, project settings, time. And so there's the fixed time step right there. That's what you're actually setting. So I get that first so that we can properly use the proper percentage of it. So this represents 2% of a second, and so we're just going to use that same ratio basically. So time dot time scale equals new time scale, and then time dot fixed delta time equals original fixed delta time times time scale. Whoops. We'll just go with the new time scale again. So what this means is if you make it 50%, it'll be 50% of the original time scale. If you make it 2 times, it'll be double the original time scale. Now, the trick with this is this scales, as I said, this scales computationally not linearly. It doesn't scale at all. If you speed up time or slow down time, you'll be doing the same amount of physics calculations and the same amount of fixed delta time for the amount of actual real time that has occurred. What that also means is as you slow down time, things will get more accurate. If you speed up time, things are going to get less accurate. So keep in mind when you're speeding up time that the problems that you already are probably having with collision are just going to get further compounded at faster speeds.
Things can easily pass through walls.
Exactly.
Doing that.
So keep that in mind if you're doing speeding up time, especially if you're doing it to a spectacular degree. So let's see if this fixes our problem now. If we hit play here, it's looking smooth.
Yeah, I mean, even the
and actually, you saw. Actually, I'm glad I had this up. I didn't even realize. As soon as I stepped in there, you saw this fixed time step here.
If you could step out of
changed.
there, you'll see
you
the
gotta try
same thing
to.
happen.
It's so slow. So slow. And my character's moving smooth now, too.
Mm-hmm.
So that solved it. Oh, fixed time step did not... Oh, yeah.
Did not revert back.
That's because...
There's no message when you exit saying that
it should have reverted back.
changes there.
That should have
Oh, is
worked.
there? I don't know why it didn't.
Let's find out. Let's see. Okay, so it changed, and then...
It did not change.
Did not change back.
Let's see why.
Wait, it's actually called Time Manager up here. I'm glad I'm not getting a conflict.
Yeah, really.
Maybe we should change the name of that at some point anyway. Why, so original fixed delta time times new time scale. So that should have turned to original fixed delta time by multiplying to 1 in this case. Weird.
Mm-hmm.
Wow, I'm moving very slowly now.
Yes.
So it doesn't get worse the second time, it just doesn't get better this time.
Correct. Oh.
Oh.
Well, the original fixed delta time was 0.02, and if you times that by the new time scale, I mean, that doesn't make sense.
It should be if this is 1, this should just be original fixed delta
Yeah.
time. This just goes away. So
It should be.
huh. Let's debug it. Let's just really quickly do just a once over on here. Connect in, Unity editor, attach, and we're gonna hit play. And we go in here. So new time scale is 0.1. Is there a way I can find? All right. So new time scale is 0.1. Can I watch this somehow? Does that work? Okay, it works. Cool. So it's 0.2. So I'm going to step over and it should change. Yep, it is changed. All right, so we're going to go back. I'm just going to hit continue. And we're going to walk ourselves out. We're walking ourselves out.
We can't walk ourselves.
It's so slow. All right, there we go. So time to fix delta time. So I want to see what this is
value
too.
is the new talent times? It should be just be 1, right?
Oops. So the new time scale is 1, and this pointer static members no instance. Oh, wait. Original
How did original time scale get down to that?
That's an excellent question. I have no idea. Okay, I think I know what I did wrong. I think I know what I did wrong.
No.
Let's be specific just in case. Let's see if this fixes it. Instance dot original fixed delta time.
Yeah, let's try it.
That's probably the problem. Let's see if this fixes it. Alright, it's working, it's working, it's working. Come on.
Come on now.
Come on.
Oh, God.
Get out of there. No, still didn't fix it. Alright, I'm going to try one more thing real quick. We're actually going to intentionally have a time manager in here as opposed to non-intentionally. I think this is maybe a side effect of something I did here. We're going to throw a time manager on it, and then we're going to do it and see if it fixes it. Oops, that's not what I want to be looking at. I want to be looking at project settings, time. Alright, so that's not right. Where is it right? Oh,
it is right.
That's actually right now. Okay.
Yeah, because it's 0.1 of what it was, which would be a 0.002.
Yeah.
That's interesting.
So for some reason, if you call this, I think it's getting called before start gets called, because it creates the instance and then calls this, and then start gets called on the next frame. I think that's what's happening. So it's not properly, figuring this out. So what I might do is floats can't be null, can they? Fixed delta time can't be 0 though either, I don't think. So here, let's find out if it complains.
Oh.
0. Okay, it can't be 0.
Yes,
Perfect.
it can't be 0.
That's what I thought. So let's just make it so it defaults to 0.0 f, and then we'll have a special case here if original fixed delta time equals 0.0 f. Then we'll just call that line.
If original fixed delta time is important, we could also throw it into awake. So it'll get called early.
I'm not sure if that would still solve this one. Let's find out, though. Let's give that a shot, just for fun.
Just throw it into awake.
Yeah, we'll just ignore that for right now. We'll throw it into awake and see what happens.
And what's the worst that's going to happen? It's not going to work.
Exactly. We'll know then. I don't think it's going to work, but... Oh, it might work.
I think it worked.
I think it worked, too.
Oh, we still have that object on there, too, so
we
it's
do.
going to work anyway,
Yeah,
so let's
right.
get rid of that object.
Delete. Thank you. Oh.
Let's see that time. Come on. Come on, let's see the time. Yep, it worked. So setting it on awake is a solution.
So interesting. Awake gets called, but start doesn't.
Well, start gets called after awake.
Yeah, but it's not getting called. Okay, but what I'm saying is, what's special about this is getting called before start.
That's very odd.
But it's not getting called before awake.
Also very odd.
Yeah. Huh.
Well, it fixed the problem, so there's that.
I'm going to go with it.
I'm okay with it, too.
Alright, cool. So, so now we have caveat number 2 covered. We now have the delta time changing appropriately with the time scale. So, let's make this cooler now. Let's make it so that we can smoothly transition to time scales. I'm going to actually change this function. Change time scale. Yeah, we'll just add it to this function. So, let's make it so that there's a transition time. So float transition time. Now what this is going to do now is we're going to make it so when you set the new time scale, if you set the transition time to like say 1, it will take 1 second to go from the current time scale to the new time scale.
Okay.
So so if we do change time scale, we're going to need private float original time scale, private float new time scale, and so new, that'll not work very well. Let's change this to time scale and transition time. So So we store the original timescale, so original timescale equals time dot delta time, or fixed delta time. No, neither of those. Timescale. Alright, so original timescale equals time dot timescale. New timescale equals new timescale equals timescale. Wow, timescale looks like a really weird word now.
Yeah.
Scale has stopped looking like a word.
Yeah, I hate it when that happens.
Scale.
This is odd.
Skull. Alright, time skull.
Okay, time skull?
Time skull. Alright, and then we're going to call a coroutine. So start coroutine. Transition time scale is what we're going to call it. And we can give it an object. So do we need anything? We don't need anything. We just set it there. We'll use the globals to sort everything out. So private void transition time scale. So all this is going to do is actually, yeah, let's have a float transition time.
Give it a float.
We'll just pass it all. I like to be consistent. Private float transition time. Transition time equals transition time. And that's not going to work very well, is it? So, I'll call it transition T.
That works.
Because this we want to be as sensible as possible because other people are going to be calling this function.
Yes.
So it does. The internal is less important than the external when it comes to interfaces. So transition timescale. So we are going to set t float t equals 0 while t is less than transition t.
Well, it's greater than transition T or less?
That should be less, thank you.
Would have made some interesting things happen.
Yeah. Should it be less than or equal to? Let's just make it less than.
Yeah.
While T is less than transition T, time dot timescale equals lerp mathf dot lerp from is original timescale, to is new timescale, and make sure that we're doing this still. Alright, so time to timescale, let's make sure that we use this instead of new timescale. I don't think we need that. Why is this complaining? Original fixed delta time. It's a real thing, isn't it? Oh, I didn't put the semicolon on the line before. That's the problem. So this is not done.
Oh.
T. All right. So this, okay, and then T plus equals time dot delta time. We'll do it. So this one has the aforementioned problem. but I'm going to go ahead and give this a shot. So we're going to set this thing up. So we need to make sure that this actually changed time scale. So we need a transition time now. Actually, let's make it so this still works. You can do default values on things by just doing, let's see if this works, equals 0.0f.
So it'll have no transition.
This should still work now. All right, so it will have no transition time. It'll be instant unless you specify it. And that's useful because now I can just add a comma here and specify it.
Yeah.
And then if I don't specify it, I get, like, change timescale still does what I would expect it to do.
Yes.
So let's make it take 1.0f for the transition. So we're going to hit play. Oh, whoops, that's just the transition back. Let's do it here too. 1.0f. So we hit play, and we go in here, and everything kind of went really fast. That didn't work. Oh yeah, that's because this just went through this whole thing instantaneously. So we need to do a yield return null here. So that'll actually just do one of these things and then go on to the rest of the frame. Yeah. And then while I'm here fixing things anyway, let's make sure that we set our time scale and fixed delta time to the final value afterwards. So we just set this to new time scale, and then fixed delta time. Just keep that line as is. So let's see if it works now. Oh, we've got a problem. Cannot be an iterator block because void is not an iterator type. Okay, we need this to be an I enumerator because that's required for coroutines. I forgot about that. Name I'm does not exist in this instance. It certainly doesn't. I'm all right. So now we go in and it still
did not transition.
Didn't look like it transitioned. Yeah.
Take out the declaration real quick just to make sure that's not causing a problem.
Which
the time float transition time equals 0.0f. I know it shouldn't do that, but let's just take it out just to make sure, yeah, that it's not actually setting it, even though it's passing through
I'm sure that that's not the case, but
never hurts to try. Yeah, it's absolutely not the case.
Too fast. Well, t is less than transition t. Time scale t plus equals time dot delta time. Yield return null.
That should do it.
You would think that would do it. While t is less than transition t.
Now you can take out that commented section now.
Yeah.
Since we know that that's not the problem.
Alright, let's debug it. Screw it. The editor. Attach. Oh!
Did you figure out what it is already?
I forgot about something. Alright, so it's not t that we want. Although that, in this case, it should just work. I'm still going to fix it. T divided by t out of transition t. Let's just give it a shot. I don't think that will fix anything other than another bug that was going to be a problem. Yep, it just instantly did it again.
Yeah.
T less than transition T. This is only calling on trigger Andrew, so that should only be calling once. Not that that would... Well, it would cause a problem if it was called twice. Let's make sure it only gets called once. It shouldn't cause that much of a problem, though. Alright, then I'm going to hit continue. Okay, it was only called once. Alright. So time.timescale equals mathf.lerp fixed delta time equals original fixed delta time times time.timescale t plus equals time.delta time, and yield return null. Let's make it longer and see if anything happens. Let's set it to like
10.
10. Yeah, let's go crazy.
No, that didn't seem to make a difference, did it?
Let's see if it's another one of these type of problems. I'm going to create an empty object, put the time manager in it officially, hit play. No?
No, that was not the issue. No.
Change timescale, new timescale, 10.0f. Oh.
Is it something really silly? Oh.
I'm surprised it even let me do that, honestly.
Yeah.
Assign to a...
Too.
That's surprising. C# is pretty friendly about that usually. It's slowing down.
Slowly
over the course of 10 seconds, and actually it's going to be more than 10 seconds. Let's count it, actually. Let's
go back to 1 real
Okay, let's go back to 1.
Because that will...
It'll be less obvious, though, but yeah, let's do that. Where's this cube thing? So you want this back to... oh, yeah. So
no, I was talking about the time that it takes to
One.
transition.
Alright, so hit play. 1001, 1002. See, it took about 2 seconds for it to do it, and it's actually a little bit less than 2 seconds. It's E's involved in this equation, actually. If you want to figure out how much how much it is, you could probably figure it out using E somewhere. So we have a problem. We have time.timescale is not reliable anymore because it is no longer a static concept. So time has a built-in function called time dot. Actually, let's look on the web. The webs is time dot timescale. So I just want to show. So here they actually show one of the caveats of making the fixed delta time appropriate. This is okay. So, except for real-time since startup, timescale affects the all time and delta time measuring variables of the time class. So, this is the only one you can reliably pull, and you could work with this one. This is not a bad function to work with, except for the fact that it's not guaranteed to be as good as the other one. Like it's reported by the system timer here. They have this caveat here. And so on certain platforms, you may get 0. It may be choppy. It may not be a continuous thing. That's the main thing. If you don't have that problem, you can honestly get away with real-time since startup and just comparing times.
Yeah.
But we're going to just be way simpler and just do a multiply to solve our problem. And so all we're going to do is, instead of doing t plus equals time dot delta time, we're going to do t plus equals time dot delta time times time dot timescale. And this should... Is it times or divided? Hold on. We want it to go... Yeah, it's divided by. So we divide by timescale. So now it should take 1 second for the transition. So if we go in here... That looked about right.
Yeah.
Let's try it again, though. 1001.
Yeah,
that's about right. And then when we leave, it's same deal. 1002.
That's pretty cool.
So it's all working.
Good deal.
So that's cool. Now we can just do that anytime that we want from any function that we want. And now functions can step on each other. If they do, we could probably set up an example. I'm not going to bother right now. But basically... Say you say I want it to go 50% speed and then I want it to go 100% speed, and you do it like 50% speed and then back to 100% speed. It will flip back real quick because what'll happen is it'll actually look probably like it's locked there if it's 1 second because it'll transition from the last time that you transitioned it to the new time. So if there's very little difference between those, it'll be very little difference between them.
Quite honestly, this coroutine might fight with itself right as it's set right now, because it's not stopping at coroutine. So if you somehow
good
got
point.
in and
Good
out
point.
of
Let's do that. I
cue-
forgot about that. Thank you for reminding me about that. So we're gonna do stop
all coroutines.
all coroutines. We'll just do the nuke on it.
So that'll just stop all new coroutines in this thread.
Yeah. So now, if you call this multiple times, it won't spam with multiple of these fighting each other.
They would literally just fight each other.
Yeah. So cool. I'm going to delete this stuff because we don't really need it. What else was there that I wanted to cover?
Oh, you could make a speed up time cube, but that's pretty self-explanatory, honestly.
Yeah. Let's do one more. Let's make it so the player is unaffected by the time scale. See, right now he slows down as well as the other things. So let's make it so when the time scale changes, he does not change. Let's see if we can do that real quick. So these guys are using the character motor. So the mouse look should still probably work just fine, because
Mouse
I think
look does, yeah.
Yeah. So mouse look doesn't care. So all we care about is either the FPS input controller or the character motor. Use fixed update. So let's see what the character motor JS file looks like. I'm just going to search for time.delta time.
There it is.
There's a few different places.
Yeah, wow. It's all over the place.
Alright, so I'm going to create another little toy here. Public float real time delta time, and we're going to that void update that I deleted. I'm just going to bring that right back.
All right.
And we're just going to have this thing always get set. So real delta time equals. Actually, why am I even doing it this way? This is stupid. You do this as a property. Let's look at our. Let's see if I remember how to do this properly. Get. And we're not going to be able to set this anyway, so get return time.delta time times time.timescale. I don't think we need that. Is that how it does? Cool. All right. So what this will do now is, if we do time manager.realDeltaTime, we'll get the time.timescale. So all I'm going to do is just I want to just change the ones in this document. So I think I'm just going to do it manually out of fear of not knowing what MonoDevelop is going to do.
Yeah.
So we're going to use. I'm just going to copy real delta time. Actually, I'm going to type it out. So time minute. Oh. JavaScript. Never mind. We're not changing this. We're not doing this right now. I'm not dealing with that.
No.
There's actually a C# version of those files that you can find online. If you want to experiment with yourself, I highly recommend it, instead of converting that from Java yourself, even though that's a good exercise if you need the practice. Just grab the C# version, and then you should be able to call it. I'm actually going to wrap that up. I'm going to call it a wrap for tonight. Right. We learned a little bit about how to manipulate time, and I think we should do one more on these, because there's just a few more things we can work with. I didn't get to show them. Actually, that's what I want to do. One more thing, guys.
That's good.
I wanted to show you something. So I'm just going to do this. Did that work?
Yeah.
That worked. Okay, so I just added some garbage music to the game. So, all right, so it's working. So if we slow down time, the music doesn't slow down with the time. And that's intentional. That's just the way that they made the behavior work. But it's actually super easy to fix that. It's really, 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 really stupid easy to fix that. So, adjust, adjust pitch to time scale. That's what I'm going to call it. And this is literally a one-liner we're going to write here. Alright, it's not literally a one-liner because it starts with like 5 lines, but as far as we're concerned, this is a one-liner. So in the update, all we do is audio.pitch equals time dot delta time, or dot time scale. You're done. That's the whole thing. And what this does is, so audio.pitch changes the pitch. It's actually not changing the pitch. Well, it is changing the pitch, but it's doing it by slowing down or speeding up the audio. That's how they actually do it. And so this is actually the audio speed is what this really is. And so if you set it to the time.time scale, it will scale with the time.time scale every frame. And this should just work. I'm going to also just be safe and put require component type of audio source. I think that's it, right? We'll find out.
There you go.
All right, so we're going to put this on our garbage music here, and we're going to hit play. And so now, once I'm going to let the music get into something, and then I'm going to go into our cube.
Our time cube.
All right, so we're going into our time cube.
Time cube.
Yeah.
Now you know that you're in the time cube.
Isn't that cool? Awesome. Isn't that cool?
Now you alternatively, now would be a good time to make a speed up cube as well.
Actually, good point. Let's do it. Let's do it real quick while we're here. Duplicate the cube
because this is just really easy to do.
Yeah. Duplicate the cube, and then we're just going to set the new time scale to 2.
And we should make it a different color.
Oh, you think so? We're going to go all that work just for... Okay, fine. Duplicate, transparent, not red.
I was assuming it was going to be green.
It is.
It's transparent, not red.
Yeah. All right, so... Point 1 is really slow, so you get a lot of the cool digital drop effect.
That's pretty cool.
It's working pretty good, and it transitions properly.
Yep.
All right. I like it.
All right.
Thank you for watching our show tonight. If you have any questions, please email me at PushyPixels@PushyPixels.com or tweet me at Drakfire. I also hang out on the Unity 3D Reddit in Reddit or wherever that is.
Reddit land?
Reddit land, yeah.
Yeah, you can email me if you want to. Philip@protosoftworks.com. You can follow me on Twitter. It's @MagmaLemur. And you should buy Proton Pulse. It's 99 cents. It's on the App Store. You can even download a free version.
I'm not sure if it's still 99 cents.
Is it not?
I should double check that. I think it's $4. I'm going to switch it back. I don't know. Yeah, sorry about that.
Sorry.
And his game actually is 99 cents because he's awesome, and it's automation. God, why do I have so much trouble with that?
I don't know.
Yeah,
it's a weird name.
Yeah, it's not. It's a good name. But yeah. So thank you for joining us. You guys have a great week.
Have a good night.